Right? All right. Hello, everyone. This is Gökhan from IOSG Ventures. I'm an investor with the firm since 2020. I will briefly talk about IOSG Ventures, but first of all, today's panel is about ZK killer apps and the survival of ZK in the future. Most of the talks today were very technical. We just wanted to touch upon what are the use cases of ZK, and maybe retouch on what is the value proposal from the ZK in general in the space. So this is what we're going to talk. It's going to be a very light talk, very high-level talk on the ZK applications. Before we start, maybe it's best if you can start with the round of introductions. Manasi, why don't you go first?
Yeah. Thanks, everyone, for joining. My name's Manasi Vora. I work at a company called Receido, where we build a general-purpose ZK virtual machine. What that means is, essentially, you can take any arbitrary piece of code and run it in a ZK environment. The interesting thing about our approach, we've targeted the RISC-V instruction set architecture, and that essentially enables developers to write their ZK code in common programming languages like Rust, C++, Go. So I think there was a question at the previous panel, what languages should we be thinking about when we are programming ZK? And I think traditionally, you've had to learn a domain-specific language. The approach that we've taken, we are really enabling ZK in common programming languages. So that's the project.
Hi, my name is Joanna Zeng. I am the head of BD at Aleo, L1 blockchain championing ZK technology and privacy-preserving qualities. Prior to Aleo, I was at Optimism as a BD lead, and prior to that, I was at Coinbase building 2 products, including institutional sales tool and an NFT marketplace.
Hi, this is Garvit. I'm the founder and CEO at Electron Labs. So at Electron, we are essentially building what I like to call as a computation compression engine. And we're essentially using zero-knowledge proofs to compress down consensus algorithms to single Groth16 proofs. The idea behind this is that it's extremely difficult to actually run consensus nodes. And especially if you try to run these consensus nodes as a smart contract on any chain. So imagine running a Ethereum consensus node on a Solana smart contract. So we essentially compress down these computations down to validity proofs, which are then extremely cheap to verify across different chains. So basically, if you don't have to run a full node anymore in order to verify consensus completely. So yeah, we work with the large L1s, as well as people who kind of need very high security bridging. Yeah.
Cool. I'm Carter. I am the founder and CEO of QED. So QED is a horizontally scalable L2, and that just means we can support applications with millions of concurrent users. And we do all this without any security trade-offs, so everything is proved end-to-end, and we submit all of our block proofs off to Ethereum, so we can take advantage of Ethereum's wonderful consensus as well.
Perfect. Yeah. Thanks a lot for the intros. Maybe to give you guys an idea, there has been around $1.5 billion that has been invested in the ZK space for the tech development in the last couple of years, and all for that is obviously for people to come and build on top of these ZK platforms. And finding a use case, finding a product market fit is definitely challenging, but I think we could argue that scaling, privacy, some of the product market fits we've found already. But I just wanted to revisit and see what you guys think about, and maybe this question you guys can all touch upon. What do you think are the main value proposals from ZK? And to build on that, what are some of the applications that are possible with ZK that wouldn't be possible otherwise? Let's start with...
Yeah, sure.
Right.
Yeah, so as you mentioned, right, ZK has been a really hot topic these days. But a lot of research has been going into the ZK industry, for the past few years, right? Aleo, as example, we have been around since 2017. With the ZKA white paper that talked about privacy, zero-knowledge execution with a privacy use case. So I think specifically to answer your question, right? So ZK really enables, really 2 things: scalability and privacy. And then at Aleo, we very much focus on the privacy aspect and from a builder perspective, what you will see is an environment that allows you to build really privacy focused. You can make it not the only option, right? It's supposed to be giving you, optionality, right, to choose to do private transfer, private transfer, private transfer, in all range of options for you to build on top of. So it's really a programmable privacy application that is previously not available to build on a transparent public blockchain. So I think from that perspective, I can go into the use cases, but I know we have other questions in the future that will touch on that. But basically, I think just to leave you guys with doing both decentralized and programmable private applications. That's now available using ZK.
Great.
Do you mind if I jump in here?
Yeah? Go.
Yeah, so I don't know, I think we may disagree a little bit, but for me, it seems like the big value proposition is that previously Web 2 couldn't, or Web 3 couldn't use Web 2 scaling strategies because it would decrease the number of nodes that verify each transaction, just because the more you distribute the load, the fewer nodes are actually checking and running each transaction. But with zero-knowledge proofs, I guess this isn't the ZK part of zero knowledge, and this is a very famous pun within the community, but specifically the succinctness that we have. And with recursive ZKP, it allows us to use those same Web 2 scaling strategies that have brought the internet to scale so that, what is it, tens of billions of people around the world? I don't know, what is the world population, but everyone can use the internet because of these strategies. And ZK, well, specifically the succinct part, allows us to bring these strategies pretty much directly copy and pasting with the added requirement to prove and verify to the Web3 world. And this is without any security trade-offs at all, so long as our underlying proof system is as secure as whichever blockchain, in the case of us L2s, that we're submitting off to. So really, at least at QED, we're very focused on bringing those world-changing applications that actually impact normal people to the blockchain. And just to go into, I guess, a little bit of a sort of you mentioned $1.5 billion has been invested into ZK. There's a lot of money going into blockchain. A lot of capital has gone into our industry. And what do we have to show for it for the normal people, right? We must take this capital, this enormous amount of capital that humanity has given us, and give them something back. And with ZK, we have the first opportunity to really do that for, I guess, the non-crypto folks.
Cool.
I can double click on that. So definitely there are two buckets when, like Joanna mentioned, privacy and scalability. The reason scalability is possible is because of this computational integrity component that ZK enables, which is essentially you now don't have to trust. You can offload computation to a untrusted party. You don't have to trust that the outcome or the output is correct. In the Web 2 sense, you essentially either have to trust the third party or you rerun the computation just to make sure that the output is correct. In the ZK context, you let them run the computation, and it also generates a ZK proof that the computation was done in a very, in the right manner. And so with that, what enables, ZK enables in terms of use cases is this concept we are thinking about called ZK coprocessor. So there's, of course, scalability, and we've all heard of layer 2s, scaling, scaling our blockchains with ETH, ZK L2s. But there's also scaling at the L1 level that happens with ZK. And with ZK coprocessors, you can essentially offload really heavy computation onto the ZK coprocessor and just have the proof be submitted back on chain and verify that chain. So a really tangible use case is, say, you want to build a on-chain auto matching engine. That's really not possible with the current smart contract limitations and gas limitations that exist today. In the ZK context, you can offload all of that heavy computation and have the matching engine run off-chain with the ZK proof generated that then you can leverage on-chain and have the settlement happen. So that wasn't really possible at the L1 level before.
Cool.
Yeah, I just want to like add one aspect to this. Like, I mean, privacy and scalability are two obvious, most talked about applications, but like ZK actually quite interesting as an execution, or rather a consensus layer, so to speak. Like, if you compare that with proof of stake, for example, in proof of stake, we essentially have this economic security model where if you have X dollars stake, that's the kind of security model you have. But if you're actually proving something with ZK, there's no economic security backing that. You actually get mathematical certainty that this thing is actually indeed correct according to these mathematical rules, which actually allows you to create these sort of novel execution environments which have no trust assumptions at all, except the mathematics for it, of course. So that's one use case I believe that we'll see for ZK.
Amazing, yeah. So like all of these, I think ZK platforms that are building now, what they're building actually is ahead of their time. If you ask anyone in the space 2-3 years ago, how long would it take to like see the first launch of the ZK VM, let's say, they would tell you 5 to 10 years. We already started seeing some of the mainnets in the space. So I understand that it is a very nascent space, but then if you want to get some mainstream adoption from the developers, it has to reach to the same level of ease of deployment as the ETH L1 or maybe even like Web2 platforms, right? So what is the state of the current developer tooling for some of the ZK platforms in the space, and what it takes to actually make it much more easier for developers to interact with?
Yeah, maybe I can touch upon our approach here. So really the motivation behind the founders starting Receiver was to make ZK accessible. Right. And again, the state of the art prior to Receiver was you have to learn the underlying cryptography, you have to understand how to write circuits, which definitely you can do, but it takes you at least, like, it's a steep learning curve, 6+ months, and that's not really scalable across millions of developers. And so the approach that we've taken, again, like I mentioned at the start, was we are abstracting all of that away, where you don't have to think about the underlying cryptography or writing circuits, and now you can write your ZK programs in common programming languages. So not having to think about the math and cryptography, not having to learn a new language, and you can access the other benefit of like accessing or using an existing language or existing programming language is that you can leverage libraries or cargoes that people have built and written over the years, where with new DSLs, you have to build a lot of it from ground up. And so that's our approach in terms of making ZK accessible. There's definitely still a lot of work to do from a developer experience standpoint, where we still need to educate people about how to use ZK, what are the design primitives, how to think about security in a ZK context. Our approach to solving some of that is just trying, as builders of this technology, building as many examples and demos and showcases as possible to just show the world what's possible with this technology and inspire developers to then build similar applications.
Joanna?
Yeah, I don't know how many of you were at my talk earlier. I was talking about this in terms of the design, the architecture design of Aleo. Essentially, if you look at the top, like kind of the tip of the iceberg, you see the Aleo SDK, right? That's the developer toolkit. But really, everything underneath is purposely designed to abstract the complexity away. So, similar to what Manasi was talking about, like we start from, compiling the language, high-level language Leo to Aleo instructions to that's the intermediary representation, and then to the bytecode level, and all the way down to the VM, the virtual machine that we have, Snark-based VM, that deals with the ZK circuit and stuff like that. So I think the point is just to get started, get onboarded into the ecosystem. It's not a huge lift for you if you already have a Rust or JavaScript or TypeScript programming language experience. And I think on top of that, I just wanted to also bring up the fact that I know you were asking about tooling specifically, but I think what we do especially well is we have been relying on the community, right? So I see like people in the developer ambassador program are in the audience. We have Evan, who's one of our grantees, in the audience. We really kind of outsource the the gaps of, like we call it RFP, or blueprint grant out to the community for the public to solve. So we see, an issue like, for instance, we need an Oracle that's ZK specific. We publish that RFP into the public, into the web for people to solve, and then we're currently kind of contracting this specific team to be a grantee to work on that problem. So I think that has been working really well for us. We have about 300 grantees in the ecosystem, and I think every single one of them is working on something really valuable for the overall ecosystem.
Cool. And developer tooling is definitely one of the bottlenecks, but there are other bottlenecks in the ecosystem as well. Like maybe you guys can talk about like what do you see beyond the developer tooling are the bottlenecks for developers who wants to build on top of these platforms?
I mean, I have to jump in though and say that QED supports normal ES6 JavaScript, the world's most popular programming language. Not like JavaScript, not like TypeScript, not like Python. We support the vanilla type. Now, major credit to RISC-0 for supporting Rust. I'm not sure that there are millions of Rust developers, perhaps hundreds of thousands based on GitHub data, but still a lot, right? And if no one is building on what, like, developer tooling, you ask if this is the bottleneck. If no one is building, it doesn't matter how well we can scale, right? So it is the bottleneck right now? Right. What do you think?
Yeah, I think for a lot of applications, like developer tooling is definitely a challenge in terms of getting developers onboarded. But for a lot of applications, like the one you mentioned regarding succinctness property, right? I think in these applications, you will not have a large number of developers developing multiple applications, but a small number of companies building these applications, which then get used widely. And I think in these applications, performance will matter a lot more as opposed to developer experience. And I think if you talk about, for example, the performance of ZK infra right now, like proving time is usually measured in several minutes, while we eventually need to get this down to, in my opinion, into microseconds, right? That eventually we should be able to generate very large proofs of very large amounts of computation in microseconds, because the user experience will demand that. Like, if you talk about a transaction, for example, today, let's say you were to use a ZK light client push to send a cross-chain transaction, you probably have to wait a couple of minutes for this transaction to happen. However, like we know that some of the faster chains have like this 1 second block time, and if you want to offer a very high quality user experience, you have to offer proving time in the same order, right? So I believe that if you have a 1 second block time, then you probably spend a couple of milliseconds or microseconds to generate a proof, but then you have to send it across. If you're waiting for more than that, then you're waiting too much and you're basically affecting the user experience. So basically performance of these systems is I believe, is a major bottleneck. Yeah.
So we agree that like the UX for both, because essentially from what I understand, and tell me if I'm wrong, but what you're saying is like the bottlenecks that we have are the developer user experience, which is based on tooling and languages and so on. And then we have the end user experience, which is based on like waiting for finality and these kinds of problems, right?
I'm basically, the bottleneck for ZK perspective is the performance. But I'm like, the reason I said performance, because I'm working backwards from the user experience here, because that's what matters in the end. Yeah, so.
Agree,
yeah.
agree. Just to push back a little bit on the minutes part there with the proofs. I mean, like, there are lots of proving systems that can generate proofs fairly quickly, like QED, proving one transaction on the client side, something like a few hundred milliseconds, doing a 4-to-1 recursion. Now we have fast recursive ZKP because of our wonderful new Fry-based proving systems. We don't have to worry about these issues, right? We have block times, 100, let's say 1 million transactions in a block. We have block times of around 6 seconds. So we're not waiting minutes anymore, right?
Yeah, you can definitely, prove specific items, for specific use cases quite fast.
Smart contracts.
Yeah, but if you start, let's say, proving generalized computation, right? I'll give you a number, right? So that if you were, let's say, measure it in terms of CPU cycles, which I think RISC-0 does, then you are, compared to a normal computation that is running natively on a CPU, you are slower by a factor of at least 100, and in certain cases, you're slower by a factor of 100,000. So that's what I'm talking about. That in terms of comparing native performance, you're significantly slower. And definitely.
Distributed compute, right?
Sorry?
Distributed compute and recursive ZKP.
Yeah, but your hardware cost goes up, right? I mean,
not that much.
No, quite significantly, right? I mean,
4-to-1 in less than 500 milliseconds.
you're missing the bigger picture, right? See,
What's the bigger picture?
you can get the approving time, let's say, down by a factor of 100. But you have to add 100 machines after that, and your cost goes up by a factor of
Well, my users are proving their own transactions. Why
Yep.
can't they participate in the block production? I only need, well, if we're doing a 4-to-1, then we all know from our math classes that we're going to need n over 3 to participate if we have a 4-part, if we have a quad tree, right? So I just need a third of people that are already proving their own transactions to donate another, let's hear it, 500 milliseconds of their compute time, 1/3, for a massive discount in gas fee.
Right.
I think this is rather reasonable.
For a use case that just relies on client-side proving, that's probably fine.
Right.
But for a lot of use cases, like the one you mentioned around succinctness, you need to deal with much larger amounts of, and it's a single machine. That
No, it is quite succinct. We're talking about like everyone receives 4 100 kilobyte proofs of, what is that, less than 10 packets? TCP
Right.
packets? Right?
I want to move the conversation more to the. So one thing that's important, I think, when it comes to ZK discussions, like a lot of people are excited about what are the use cases for ZK within the Web3 space, right? And scalability, privacy are some of the things that we've mentioned. But then a lot of people are also interested in, like, is ZK going to provide some value add to some of the Web2 applications or Web2 world, right? So maybe let's move the conversation up to the app side again. Do you guys think it's going to be helpful for some of the enterprises, some of the Web2 companies or users, what we're building at the ZK side? Manasi, you wanna start?
Yeah, I'll definitely take this. I think as a company, we believe ZK technology definitely goes beyond blockchain Web3 applications and use cases. Definitely, that's the first place, and there's a lot of demand there. So we are very focused on, scaling blockchains, scaling DeFi applications, bringing privacy on chain. But there's so much more that ZK can enable, and it doesn't even have to touch crypto or blockchain. And to make it concrete, there's one level which is bridging the Web2 and Web3 world, which we are exploring currently, which essentially is taking off-chain data, which already exists in the Web2 world, for example, identity, and bridging that and bringing that in a trustless manner on-chain, so you can leverage, traditional identity on your smart contract. An example of that, we just launched Bonsai Pay, which enables you to send crypto assets to a Gmail account. You don't even need to know the person's wallet address, or the person doesn't even need to have a wallet to be able to send them crypto now. And this is enabled because we are bridging, taking Google's OIDC, JOT tokens, proving them in a ZK manner, and associating that with a wallet. So that's one use case which, bridges Web2, Web3. Pure Web2, I would say there are so many, when we talk about privacy, so many use cases in the healthcare space, in the identity space. Another concrete example, the National Renewable Labs in the US, which works under DARPA, controls or monitors and does research and development for the energy grid, they've actually written a paper on ZK to use ZK in control grids. So, again, going back to the computational integrity part, where you don't have to trust the different nodes in the electric grid and still can take those inputs as valid inputs. And that reduces just the vulnerability factor and increases security. So there's so much. I think that the Web2 world is really unexplored when it comes to ZK use cases.
Right.
Yeah, I would like to just add to that. Definitely think that it is the reason why we believe that ZK is the what's the right word? The trigger for the next mainstream adoption, right? I think specifically at Aleo, as I mentioned earlier, we focus on privacy use cases, and privacy is the most underrated or most misunderstood concept out there. When people talk about privacy, they think about maybe just money laundering, right? Using like dark web or ISK technology. But what we were talking about is we're actually talking to the many enterprise users about building these compliant and private solutions that enables them to programmably build these configurations to add this compliance layer on top of something like a fraud detection on top of the like a stablecoin, for instance, stablecoin transfer. So we very much want to bring these Web2 players into the Web3 world. One example is we recently just launched this product called Z-Pass, which is something that we internally dog-fooded our own tech stack. Z-Pass basically is a self-sovereign identity solution that can be used for a range of scenarios. One particular scenario that I'm very excited about is we work with this company called Common Sense Media. So they look at these school kids' age verification, and they provide that to the internet providers like Netflix and other like Disney, content providers in the world. So we are the technology provider in between these two, the content providers and basically the school age children, right? So we provide the attestation layer on top of this existing KYC infrastructure. And that's something that we see having a real world use case, right? Not just, we don't even, like when we pitch to these companies, we don't even talk about us as a blockchain company. Right. As a matter of fact, we just say that we are a technology solution provider, with zero knowledge proof at the core.
All right. Given the limitation, maybe I have one more question for Garvit and Carter, but let me open it up to the audience. All right, yeah. So then maybe one more question from my side, and then I will open up to the audience. So where do you guys see the space going like 3 to 5 years from here now, right? What do you think is the worst and best case for ZK technology? Where do you see the adoption?
Sure. So I think rather than just 3 to 5 years, I would if you talk about very long term and probably talk about end game. So I would say there are 3 areas which kind of we'll see. So obviously developer experience is one which we've discussed. Performance is definitely another one that we've seen happen here. But I think what will happen over the long run is that the cost of proof generation will essentially turn down to zero. Right. Like as we saw with payments that in certain areas that the cost of payments is zero, we will see the same with zero knowledge proofs. And what's going to happen as a result is that people will generate zero knowledge proofs for pretty much everything, right? So right now we do it only when we absolutely need it because it requires a significant amount of capital actually to be invested before we can start generating these proofs. I think what we'll eventually see is that, so for example, if you talk about a developer today, when they compile down their code, once they build the code, they basically deploy it. I think one of the things they'll also do in pretty much all use cases is they'll also generate a proof of that and share that. And they'll do that because there's some added benefit of that. And even if it's a good to have use case, they'll do it anyways because it will be essentially free to generate these proofs. So we'll have pretty much zero knowledge proofs for pretty much all programs being executed everywhere. And given the fact that generally things are moving towards trustless computing anyways, it will make sense to have these proofs come as a receipt for pretty much everything. So yeah, I believe that's kind of the long term for zero knowledge proofs.
Right. Have we all forgotten Web3, why it's called Web3? If zero knowledge proofs can enable us to scale the trustless compute technologies, call it blockchain or whatever you want, to Web2 scale, then shouldn't that mean that zero knowledge proofs are what make Web3 become Web3, right? Shouldn't we want, we spend all of our time on our devices. I spend most of my time on my devices. That's why I've got a little, but, maybe I should spend less time. But most of my life is on the internet. And right now, that life is controlled by one of a few large platforms. And as a species, we're moving towards our whole lives being on the internet. Now, do we want to live in these little, technological dictatorships ruled by, some people like Elon Musk, some people don't, but there's multiple of them. I don't want to say anything, we love Amazon though, of course. But we do, we love Amazon. But, we need, as a species, if we are going to live in the digital world, we need a fair way to do it. And currently, the compute model does not give us that. But ZK can. So where is ZK going to be in 5 years, 10 years down the future? Hopefully, for the interest, I think, of everyone in the room, moving towards that. Not just financial applications, although financial applications work great. Hopefully, we see more and more and more new applications that didn't work with existing blockchains start to work with trustless compute. I don't know if that's something that is shared by my fellow panelists. I hope we're kind of all on the same page about that. But yeah, ZK is the future internet, right?
Perfect. Thanks a lot. So let me open it up to the audience. Please raise your hand if you have any questions, and we're going to bring the microphone. I'm sorry. First, we will have to take behind. We'll come next.
So my question is, Joanna touched upon the application. They have for kids using certain applications. So my question is, do you see applications, I'm not talking about the blockchain space here, but outside, I don't know whether you call it Web 2, like the network security, where you have the DDoS kind of attacks, and also like malware kind of stuff, getting into one's computer and doing damages. So do you see ZK applications, and are people looking into that? I'm just curious to hear you guys' views on that.
I come from a security background. I was previously in a hacking gang as a child and was arrested, but did not get a felony because I was a minor. But yeah, so I have some hacker background. Maybe I can touch on that question. But yeah, so like I think for certain applications, probably less on the the end user side, more on the server side, where like you want to make sure that one server hasn't been compromised by malware. You can do any like mission critical computation that it's doing and prove it. And then I guess some other server doesn't have to just blindly trust the result of that one server. So even if you hack into the server that's doing this critical computation, you don't have to worry about if it's been compromised or whatever. Maybe you have another air gap system that's going to be ingesting the result. But I guess that works. But I'm very bullish on ZK, but I don't see it like us running an OS on it. Although I know RISC-0 has booted Linux, and congratulations on that. But I don't know, maybe RISC-0 has a...
Yeah, I think it goes back to what I was saying earlier, the computational integrity piece that ZK enables, where now, you don't have to trust the output that comes from a random, outsourced computer. And you have a ZK proof that's generated with that output that can be verified. And you trust that the program it ran was ran correctly because you're verifying the ZK proof, and it's cryptographically secure. So that's all I have to say.
Cool. Let's take another question.
Hello there. My question is for Aleo, but others can take it too if you like to. About this particular claim that decentralization, scalability, and privacy aren't mutually exclusive anymore. Could you please expand on this a little, like in terms of your performance predictions? Like realistically, how far do you think the Aleo system will scale? And a second question again for Aleo: why did you, in the Leo program line, why did you prefer a low-level approach? And what do you think this brings? Thank you.
Sorry, the second question one more time.
The Leo language, why is it using a low-level description? Why did you prefer that, right?
Okay. So the scalability question, right? I think basically the way that we've been looking at scalability is just using off-chain compute model. So all the everything computation-wise is happening off-chain. That's why there's technically no gas fee or technically no transaction fee unless it's running on-chain or in a shared state. And then on the zero-knowledge verification, that's when you first finish your computation, then you will bring the proof on-chain. That's the only portion that will bring to the brought on-chain, right? So that's why from a scalability standpoint, it's similar to like a roll-up, for instance, right? It's very scalable. Yeah.
Right. But how scalable? Like in terms of performance numbers,
like
transactions
a benchmark
per second for, say, an expected or average smart contract size?
I don't know if we have a TPS per se.
Yes, I was just wondering what kind of study you did on this, like theoretical or,
Yeah, I think depends on, let's just use a simple transfer as an example, right? It's, let's say, like an NFT private mint, it's going to take you maybe like 30 seconds to complete, right? So it just depends on the complexity and the size of the application. The actual application running time will be dependent on that.
All right. All right, that has to be all. Thanks a lot, everyone, for coming and joining us. Thank you for participating.
Thank you.
Thank you.